He's been quoted hundreds of times and written about hundreds of times, won many, many awards, and his work has been featured in museums and books. And one really fascinating area which David has been pioneering is restorative architecture, which is the idea that buildings shouldn't just have a low footprint, they actually should be giving back. And one of David's companies that he's founded is looking at how to take air out of the atmosphere to put back in the system because of the issues around water shortages, which we've seen most saliently in Cape Town at the moment. David. David's still getting a microphone on. Just one other quick point is David is responsible for a house nicknamed the Californication House because it was featured in the American TV show Californication, and it was developed based around Balinese architecture. And I actually speak Indonesian, which is not particularly useful in this part of the world. But I've been to Bali many times and I've seen that type of architecture, and it is really one of the most beautiful houses, and it's really synonymous with the architecture now of Venice Beach in Los Angeles. And it's definitely worth, when you get home, have a look at the Californication House and David's design. David Hertz, welcome. Do you have a design?
A perfect example of sustainability and design. So today I'm going to talk a little bit about kind of where we are with either abundance or scarcity, how we look at it. But I also changed my presentation this morning from this new news because Donald Trump has just announced the sale of California to Mexico. So we're very, very pleased being in California about that. We look forward to being part of your country. Or having part of your country back, I should say. But really, this is our home, our pale blue dot in the atmosphere. It's quite amazing when you have this perspective of our planet. We only had this view since 1976 of spaceship Earth, as Buckminster Fuller called it. I think when you have this type of view of the planet, and you realize that we're on this thin veil of our atmosphere, then you have a little bit more of an appreciation of the resources. We look out at this incredible ocean, and it looks vast and infinite, but we really realize how really finite our resources are when we look at it with the lens of the atmosphere and how thin that is and what our resources really are. So being aware of the finite resources, understanding that nature is incredible. I mean, it's had 4.6 billion years of research and development. No species are unemployed. It takes waste and it turns it into food. So there really isn't a concept of waste. So we can learn a lot as humans, really by the engineering and the design, of abundance. Because nature certainly has abundance. It's just that perhaps we haven't, as mankind, developed the skill sets to really use our resources efficiently as we can. So that's kind of what I'm going to talk about. It's a little bit about the man's perspective, right? We've had anthropocentric view, that is a man-centered view of our planet, really versus a biocentric view, which sees us as part of all the other species. Many indigenous cultures have a view that they are part of all species, not, say, dominion over those species. So our perspective might be an ant is very, very small. But when you realize that the biomass of ants on the planet far exceeds the weight of humans and all animals, it changes your perspective. There's over 1 million ants per human being on the planet. So something that seems small really can have tremendous impact in terms of the volume. And similarly, we need to kind of change the way that we look at our economy. Kenneth Boulding, the famous economist, looks at shifting away from this kind of cowboy mentality, which in America we've had tremendous resources. And so it's been really an evolving culture of, cut it down, drill, burn. And that's based on this kind of infinite resources, because we look out and there's forests and there are infinite resources. But now, when we have this perspective looking back at a kind of spaceship Earth, then what we take and make on the journey is absolutely critical, of critical importance. So that's kind of the linking to the roots of ecology and economy. If you're efficient and you don't generate waste, that's also economical. So you can really do well by doing good with say, manufacturing and being more efficient is also being more ecological. So man, of course, has been usurping a lot of primary resources. This is a real image of a mining town. And it just speaks to the extraction, the amazing ability that we've had to extract resources in largely inefficient ways. I mean, our industrial system, one could say, is largely broken and in need of a redesign. And many people can be involved in the design of new systems. So overshoot and beyond the limits, beyond the carrying capacity are often words that's looking at scarcity model. And one could also say, well, how do we work more efficiently, economically? Now, a large part of this is, of course, because of this construct that was a design, by design, an industrial design construct, which was to create consumerism and capitalism. And that is, to create an object and then to make that object obsolete, even if it's still good. That fuels an economic model and an engine, and it consumes a lot of resources. So what we kind of take, and being aware of what we take, what we make and how we make it, and what we waste, is sometimes something that people are unconscious about because of the vastness of our geographic limits. So I'm very interested in the idea of repurposing, the concept of ephemeralization within the kind of man-centered metabolism of our now technosphere. Ephemeralization is a term that Buckminster Fuller had, really to do more and more with less and less until everything you can do everything with nothing. I mean, that would be the ultimate idea. You can achieve so much more with less. That's less resources of what we take and extract from the earth, more efficient in the way that we make things, and less waste. So anthropocentric metabolism, if we think about it like nature, it is basically the entire collection of all the processes in manufacturing things that take and extract raw materials plus labor into the finished product, and also where that goes. So part of what we're really interested in, and I've been interested in, is where do these things go? What is the casualty of a model that puts so much emphasis on planned or even perceived obsolescence of objects that actually have a good potential service life? So in nature, we know that there are nutrients where waste equal food. And in manufacturing and industry and in technology, if we think about the same model and we learn from 4.6 billion years of research and development, we can think about our waste as nutrients, as technical nutrients. And that could really inform our processes to be more efficient, more ecological. So as an architect, I've been trying to rationalize my place first as an environmentalist, and then in the built environment, as how do we lessen the impacts of the built environment on the natural one? Now, buildings account for 1%, or their number one global emitter in the U.S., way ahead of transportation and industry, which is staggering. I don't think people would necessarily think about buildings, but when you think about the embodied energy, the transportation costs, the operating costs, the electricity, the CO2 emissions, it starts to make sense. It has a huge impact on our society, and that's the intersection that I'm interested in working in trying to lessen the impacts of buildings. And green buildings, in a very short period of time, with the advent of things like the United States Green Building Council that created LEED, with the Living Building Challenge that even goes beyond LEED, have made significant reductions. And this is an example of abundance and ingenuity, identifying the problem. Maybe like a doctor might first have to realize that somebody has an illness, might go through a denial phase, an acceptance phase, and then a phase of trying to actually do something to correct the problem. And we're now in the building industry in that phase where there's no longer a question really of the impacts. It's how do we be more efficient? How do we do more with less? And so what I've been doing since I opened my studio in 1983 is I have a boutique, small, multidisciplinary design firm that creates buildings and materials development and technologies. And we're very interested in that intersection between what can technology do and how can we lessen the impacts. I invented a building material, reluctantly, a precast lightweight cement-based composite that uses materials that are shown here in the bottom that are extracted from society's waste stream. Off-fall material that fall on the factory floor, everything from plastic regrind to brass screw shavings, to records, to cassettes. I started to look at the industries that created waste. Many products are subtractive products and processes that create more waste than the finished product, especially when they're commingled and they don't have the ability to be recycled. How can we mine those for their creative potential? And I created a company with this product and then sold it to a large public company. And our designs range from something like this light fixture, a very large light fixture made from a found object of a sailboat mast, to being involved in new surfboard technology that uses polystyrene foam, and instituted a collection system of polystyrene, which is not currently recycled, into new surfboards. A dress for a fashion show made out of high-density polyethylene bottles, for instance. And so, as Javier said, this is about trying to design, to come up with beautiful and functional designs. I was commissioned by the World Surfing League to design their perpetual trophy, and so sometimes our designs are small and highly sculpted. Everything was 3D printed and manufactured with no waste. And speaking about Tesla, conceptual designs to look at how we would design a building in the future for a launch control facility in Cape Canaveral. How does the building become essentially a beautiful object that would portend a future that would make the building as beautiful as an object? And we were inspired by the trajectory, of course, of flight. So our scale ranges from a small product, material. It started really with furniture design, and is very interested in the idea of restorative homes in particular, homes that offer a certain respite and restoration from our daily lives. This is the Californication house, as we referenced earlier. That was inspired largely by a lot of my travels in Southeast Asia. It became a model in many ways for indoor-outdoor living in California. It generates 100% of its own electricity, captures 100% of its own water, and provides a healthy and natural and living environment. And other homes really utilize recycled materials, prefabricated systems, living walls, and other things. So these are just a few examples. Here's an example of radical reuse or repurposing. I designed an automotive museum for a private collector of French race cars, primarily Bugattis, and I use windshields as the entry canopy so that there's an obvious tie-in. How do we turn something beautiful using existing materials? A hotel project which is about adaptive reuse of existing buildings, a pier that had been abandoned, and how does one envision the creative adaptive reuse of an old pier into a technology hub and a center for marine sciences that generates its own electricity and resources within the existing buildings. An arts complex that was an old factory in Santa Monica that is transit-oriented, that incorporates a museum, a hotel. So some of these are larger projects, but they have a very, very strong emphasis in lessening the impacts of those buildings. So this idea of restorative and regenerative goes beyond sustainability. Sustainability is defined in the Rio Conference is providing for the needs of the present without detracting from future needs. But it really doesn't go far enough because we've had many, many years of destruction where we have usurped resources at a faster rate than the planet can replenish that. And so something that is restorative means it gives back more than it takes in very simple terms. So here it's kind of beyond the point of minimal or no environmental impact. It actually becomes a vehicle for restoration and like a living ecosystem. So it's a next stage, really. And we hope that we can evolve that. And what I would suggest is, what if our buildings can generate more energy? We talk about net zero, which is fantastic. Why can't they be more than net zero? I know in America we have a federal net metering act that requires the utility to buy back the power that you generate. So there's an example of a building that takes, is oriented towards the sun. It uses nature. Artificial lighting works in an intelligent way with sensors, with daylighting control. Buildings that are beyond smart buildings in the future in cities will become intelligent buildings that are buildings that anticipate the occupant's use. Imagine walking down a hallway, the lights turn on in front of you, they turn off immediately behind you, and that's a building that is intelligent, a building that is responsive, that learns and adapts. So there are some examples of that. There are ways that technologies can be integrated. Solar photovoltaic. I had a project where I used solar. I cleaned the solar to make it more efficient, taking that water, dropping it into a green roof so that you have multiple solutions to a problem. Here's a concept for a bridge across a canyon, which is a natural air funnel. So why shouldn't the bridge utilize that air with turbines to make energy and to create green space? So that's thinking creatively, making a beautiful object, and harnessing natural forces. Here's the idea of a building that can utilize the wind energy at the top of the building, actually wind that is accentuated by the building itself to create more intensification of wind and vertical integration of vegetation. What if buildings can actually create habitat? Let's say an empty piece of land, maybe this hotel at one point, there might have been a habitat here. What if the building created more habitat by understanding, the migratory patterns of the animals and species that were here? This is a green roof research station that we generated that led to this design of the California Science Center, where the whole building is a vegetative roof. It becomes a monarch butterfly habitat, increases bees, becomes beautiful to look at. So this is the kind of architecture that portends a future that is beautiful and sustainable. Buildings have more surface area often than the footprint that they were on. This had a small footprint. The walls and surface area are larger. If they're vegetative, they can generate more oxygen. You can clean water. This is a building that actually takes all of the water off the building and generated by the building into a kind of green machine, an ecology that uses natural processes to filter that water. What if they return more water than they actually use or took from that by capturing it? Here's a building that actually takes all of the black water and the gray water and processes it all the way to a potable standard. So that technology exists. These can be integrated into beautiful natural systems as well. Here's an idea of what a building could be in a city where it starts to become more organic in its form and more representative of kind of what nature would do. It's easy for man, given limited tools, to have a straight line. That's a very simple form. You don't see a lot of straight lines in nature. And in that diagram that was shown this morning, it was so interesting, that node and then the node that the computer made is much more what nature would do. So even if we're dealing with some rectilinearity, still just adding nature as a canvas. This is, of course, what our cities would look like if we're gone, because nature is going to go on, whether man is part of the sixth extinction of the species or not. It will certainly take over. But buildings can actually even generate soil. I mean, they could become armatures for harvesting. For instance, even become your supermarket. Why should you transport materials at great energy costs, basically transporting water and weight, when a building that one could live in could be your supermarket on site, right? This idea of food table, anything that we can do to minimize the transportation will be far more efficient in our system. So here's automated growing systems that have been engineered to control indoor environments, to increase production rates. When you think about our antiquated methods of farming, of vast open tracts of land, spraying water into the air, flooding fields, you can get a tremendous amount of yield out of smaller buildings. And we need to be more efficient about our growing, because the World Health Organization and the World Resources Institute project extreme food scarcity in the future, and we need to use design to get there. What if the buildings actually even harvested the food? We can use advanced intelligence and AI to create food systems where they're more automated and increase productivity, and that's starting to happen more and more. The idea of a living tower, vertical farming, again, in areas that we saw earlier today, how many people are migrating from an agrarian, open landscape to a dense urban city. So what if in the city we still created our these kind of farm scrapers that that could incorporate. So these are ideas about the way the future could be in terms of living towers, vertical towers that capture the sun and provide food. Buildings can become an armature for nature. And Frank Lloyd Wright said a doctor can bury his mistakes, but an architect could only advise his client to grow vines. So, even if you don't have the best of architecture, you really can't go wrong covering it with nature. The idea that buildings consume so much CO2, what if they actually produce oxygen by this green matter and absorb CO2 in the buildings? In the biosphere, one of the reasons that the biosphere failed is they found that the concrete absorbed the CO2, the concrete foundation that was there. So what we do in the future in our carbon society with the absorption of CO2 is one of the fundamental issues of carbon sequestration, and buildings can be part of a carbon sequestration. They can also convert waste into energy. There's biogasification, there's heat recovery, buildings generate heat, so that the waste can actually become a nutrient. And even in the future, what if buildings grew themselves? What if they became genetically modified or used nature? When you look at a tree, for instance, it's incredible. I mean, and if you have a tree, what happens when you have many trees? You have the biodiversity of a forest. And so cities start to act like forests. And what a tree does, amazingly, is it creates oxygen, captures carbon dioxide, distills water, uses solar energy as a fuel, makes food, creates microclimate, enhances diversity, creates beauty. I mean, trees don't go out of style. They're responsive to changes in climate, and it self-replicates, and it creates zero waste. So our buildings in the future could learn by something as beautiful as something like a tree. So talk a little bit about mining the waste stream. We talked about radical reuse and repurposing, or super use, really, where design and recycling meet. When we look at our processes, typically our processes have been linear. We extract raw materials, we manufacture them, they go for consumption, they go to the landfill. Now we've started to look at, okay, well, let's cut that cycle short and let's recycle so that we're minimizing some of the raw material extraction. But reuse goes so much further, because now you're not even back into the manufacturing portion at all. So you've eliminated both materials extraction and manufacturing. There's the concepts of recycling, but there's also upcycling and downcycling. What if we take objects and use them for a higher and better use? So for instance, aluminum, one of the highest embodied energy building materials, if we use that, we minimize raw material by almost 95% of the energy. So this is an example of taking, say, an airplane, like a 747, and turning it into an aluminum can. That's a radical downcycling of that. And so I began to be interested in knowing about that, and I had a concept of repurposing wings of a 747 into a house, and taking those wings, the two wings and the two horizontal stabilizers, and building a house out of it. And it would be very light on the ground, and I began to look at how beautiful the shapes of buildings were. And so I convinced my client to buy a 747. It's a $357 million airplane, and we bought it for $35,000. It's kind of a radical devaluation of price. So we took the airplane away from the herd, and we cut it up. We put it on a truck, the wing, at 47 feet wide, 125 feet long. We closed 5 freeways. Under police escort, got it to an airport 10 miles from the site, cut it in half, and used a Chinook helicopter to carry the wings to the site, which is very, very remote and would have required lots of little pieces and lots of transportation. So this concept is a large, less strategy. Large pieces that are fewer pieces. And when we calculated the carbon footprint of what we would have done building a conventional building, instead of repurposing and reusing, we found that it was the equivalent of over an acre worth of forest in terms of CO2. So here's some examples of the way that it integrates into the landscape, unlike a conventional building. The wings cantilever, they are very aerodynamic, they're sculptural, they taper. These are the two horizontal tail stabilizers. They have wonderful shapes and look good with the human form. They float, they're reflective. We incorporated lighting. And so ultimately, this is the case where the progenitor was about design, making a sublime and beautiful architecture that integrates in the landscape, that's efficient, but it's also about radical reuse and repurposing. This last project is currently a project I'm doing an eco-resort on the island of Bequia in the Grenadines. Everything on an island you're very aware of, just like on our planet. Where the waste goes, where things come. Everything is being imported anyway to an island, so we're actually building all of the structures in Java. It's all designed to be flat pack. The roofs are sails, are tensile membrane, so they fold up. Every column and beam folds down, and there is no water there. So the water is collected off the roofs. I've looked at other projects on islands that really look at what do we have as a resource. Perhaps we have coconut husks, the roots, those can be converted to energy. And so what I want to finish with is this idea of kind of precipitating change and understanding water. Water is absolutely a fascination of mine. It comes from outer space. It's not indigenous. The amount that's here is the same amount. It just changes its state and oftentimes just gets dirtier. The distribution of Earth's water is actually quite staggering. About 97% of Earth's water is in the ocean, is salt water. When you look at it this way, you see how little that is. So you have 97% of water is salt water. Of the 3%, about 1.5% is frozen and rapidly becoming salt water. So you have less than 1.5% of fresh water that's unevenly distributed across the planet. Now, there's more water in the atmosphere at any given time than all of the rivers on the planet. So it's quite amazing when you look at vapor. Now, NASA recently came out with that 4 billion people are at risk as the water tables are dropping all over the world. Water scarcity is much worse than even anticipated. 2/3 of the world population is at risk, and this will be one of the most difficult and important challenges of the century. We know we can survive without gas, without other things. We cannot survive without water. Now, the UN says that we have less than 12 years to avert a full-blown water crisis. By 2030, demand for water is going to outstrip supply by 40%. It's a staggering thought. The consensus of all health professionals, of course, is that water supply is the most critical factor to human health. People die, even 90,000 people a year in America, 80% of illnesses, and human population without access to safe water is expected to rise over 1 billion people. My wife Laura and I started this Go Water initiative to try to help people with the water crisis. This is a app and website that to people in Cape Town that gives them the countdown to day 0, which is in less than a couple months away, where the water will be turned off. This was a reservoir in the full capacity of the reservoir, and that's the level this January. It's now getting to the point where they will be shutting off the water because the silt of the bottom will be clogging up the system. This is what's happening today. Water is life. We're scared. this is what it's coming down to due to lack of foresight, due to large infrastructure mentality that moves too slow, because our weather patterns is now at a point where the past is no longer used to predict weather. The past is not prologue. And this was a fascinating photo that I saw that really struck me, where this guy's looking at this pool half empty, but there's all this vapor right in the mountains above. I thought it was very interesting. And so this is indicative of this idea of, is the glass half full? Is it half empty? Now, 14 of the last 15 hottest years on record have occurred since 2001, with, of course, 2016 and now 2017 being the hottest. Insurance companies have modeled global climate change. They wanted to understand that. They predict a 500-year storm, one storm in 500 years. There have been 4 500-year storm events, well, 3 500-year storm events in Houston and 1,000 storm event in the last 5 years. It's staggering. Now, as the temperature increases, the oceans evaporate more moisture into the sky, and water scarcity knows no boundaries. It is a global problem. You can see the regions. When you match this with atmospheric water vapor, the kind of area, it's about 15 to 18 degrees north and south of the equator. It turns out that a lot of the areas of water scarcity and water quality issues are in hot, humid climates. So there's about 37.5 billion gallons. If you were to condense it at any time, that's 1 inch of water around the planet. Americans are very consumptive. We use 100 gallons per person per day. If you look at it in terms of cubic meters, you're 1,583 meters. Mexico, for instance, 690. Germany, 404. So part of it is our attitude towards the resource. And we need a disruptive technology to change the model. And the sky really should no longer be the limit in terms of what's possible. We have a confluence where water is becoming the single highest cost of utility, but energy cost is falling to unprecedented levels. When we thought about energy progress in 2002, 1 GW per year by 2010, it's exceeded by 73 times that. That's huge, the demand. You look at the cost of silicon, it's gone down radically. You look at the cost, a number of world solar installations have gone up radically. Companies like Tesla leading the way. So we've been involved with a technology called atmospheric water generation, and basically we extract the humidity in the air to make pure distilled water. The industry looks at this becoming a $8 billion industry by 2022. Right now we're competing for the X Prize in water abundance, and what we're looking at is ways that we can have an adaptable system that responds to local cultures, local climates, and essentially creates an ideal climate for atmospheric water, even if none exist. The technology has several patents called adiabatic distillation. We've looked at biomimicry as an example. The Namib beetle, for instance, uses a hydrophilic and a hydrophobic coating, a coating that attracts water and then repels water and marches that water down that beetle's back in the middle of the desert and right into its mouth. These are types of systems that are very, very interesting. We've been generating water farms, this one in India, where these things could be generated. It's about distributed water, much like distributed power. 17% of all California's energy is coming through the pumping and distribution of water from long distances, when each building could make its own water. We use biogasification in rural communities. This is a SkyWater machine making water out of air. So the idea is a systems approach. Here's where, in a concept where wood or raw materials can be dried, the moisture can be extracted, that water can be generated to grow food and to create jobs. If you have a different climate, there are food production systems in place inside something like a shipping container where you create an ideal climate. These are things that we're looking at in our testing, where we're trying to use natural systems to harvest water. We're also working with Deepak Chopra in India, and the concept in an urban environment is, why don't you take a billboard that exists as an armature, turn it into a beautiful vegetative wall and garden, and capture that, filter that air, even in a dirty city, and bring that water down the column to activate the social space like a well. So here's an example of an aeroponic food tower, using solar, making water to grow food. And what I want to end with is a very short film on what we're doing in Venice right now to actually make water using solar energy and to give that water away to the community. So,
where does water come from? The water that we have here is the same water that we've always had and we always will have. So you have a closed system with a finite amount of water, and it just gets dirtier. I've just been very, very interested in water as someone that's been involved in the water and the ocean my entire life, but also the importance of fresh water to mankind. And being in California, the issues are fast approaching crisis proportion. I started off really as an environmentalist, and so I had to rationalize my place in the world as an architect. So I've been moving from sustainability towards a restorative architecture. 71% of the planet's surface is water. 3% of that water is fresh, because 97% is salt water and is not drinkable. This 3%, half of that is ice. Of that 1.5%, 0.22 is atmospheric water. That's water vapor in the atmosphere. And you could essentially condense it into water. That little 0.22% turns out to be 37.5 billion gallons of water per day. Point of use is so critical because it's the same thing as farm to table. You have the sun, you have the water, you might as well grow food.
David Hertz said to me, I can solve your water problem. He's like, I have a machine that makes water from air.
This technology, SkyWater, uses adiabatic patented distillation process using refrigeration technology to essentially extract water out of air. Looking at it, we thought, let's offer SkyWater to community healing gardens, so the boxes are grown with water made locally.
David's a godsend. So many people have yet to know and understand what David's offering. It gave me an opportunity to work, but we're reducing a footprint at the same time.
That social experiment started to expand. My office is right in the epicenter of Venice. There's a large population of transients. Let's put in a bottle filling station in the alley, incorporate that with street art, almost like an urban well, a sky well that would provide water to those in need. The simple, fundamental human right to water is surprisingly, even in our wealthy first world country, an issue. And I've been amazed at how well received it has been by the community, especially by those in need.
Great. Okay, well, thank you very much. You want that?
Much, David. We'll just have a short 10-minute break, and then come back and we'll have the panel wrap up before lunch. So just 10 minutes, grab a coffee, and then come back. Thank you.